Imagine that you go walking on the beach. Of course, you know that the beach is made up of tiny particles of sand. You also know that your shoe is made up of particles called molecules, and that those molecules are made up of atoms. So if you zoom way, way in on what's happening where the shoe and the sand come into contact with each other, you would see something like this, where the shoe, which seems to be pretty solid, you can't see any space between those molecules. You can't see those molecules, but the sand, you can see the different grains of sand. So you would have something, if you zoomed way in, you would see something like this, where the shoe rests on the particles of sand. But then if you zoomed in even further, you would see something like this, where each grain of sand is made up of smaller particles, smaller molecules, and each and the shoe also is made up of smaller particles. So the particles that make up the sole of the shoe and the particles that make up the sand push against each other, but they remain separate and they don't combine with each other. Now, you also know that those particles, those molecules, are made up of even smaller particles. You know, they're deep, deep inside there. There's a tiny, tiny nucleus. And then these spherical or circular shapes represent electron clouds. And the electrons are incredibly small compared to the size of the atom. So, well, these are molecules. But the molecules are made up of atoms, and atoms are made up mostly of empty space. So why is it that you don't just pass through the sand? What keeps you supported on the sand? If you have all these different particles and space between the particles, and even their shoe, which seems solid, is made up of particles that are made up of mostly empty space. Think about what does it mean to actually be in contact with another surface? Here's a model of an atom where we have the nucleus. And remember, this is way out of scale, because the nucleus, if we drew it, if we drew an atom that was the size of this yellow cloud, then the nucleus would be so small we couldn't even see it. So the nucleus is enlarged here to show where it is in the middle of the atom. Then there's the electron cloud, and the electron cloud is really a probability map. It shows where the electron, or electrons in this case, because we can see that there are many protons in this nucleus, so there must be many electrons in the electron cloud. But where the electron cloud is darker, that means we are more likely to find electrons there. And where the electron cloud fades away, that means that the electrons are less likely to be in that location at any one time. So if we are going to develop an analogy for contact force using a macroscopic object, macroscopic means like big enough to see or handle, not tiny like electrons and nuclei. If we use a macroscopic object as a conceptual model of an electron cloud, we would think of something like, maybe if we wanted to envision contact between two atoms, we might use something like two cotton balls, right? Because when the cotton balls come into contact with each other, they slightly deform. But it's when the very edge of the cotton ball comes into contact with the very edge of the other cotton ball, then there's less deformation, and as they come closer together, they become more deformed. You could also think of soft foam balls, not like Nerf balls, but even softer foam balls or pillows as models for atoms.